Hello everyone, this is Aishwarya A, currently studying in 6th semester, Department of Electronics and Communication Engineering at Sri Venkateswara College of Engineering, Bengaluru. Today I am going to present on a topic Gram-Smith orthogonalization. First and foremost, what is Gram-Smith orthogonalization? Gram-Smith orthogonalization is a procedure or a process that takes a set of linearly independent functions or vectors and constructs an orthogonal or orthonormal basis over an interval with respect to a varying function or an inner product. Now we'll discuss a problem on Gram-Smith orthogonalization, and the problem is, for the given signals S1 of t, S2 of t, S3 of t, S4 of t as shown in the figure below, find the set of orthonormal basis function using Gram-Smith orthogonalization procedure. And the graphs of S1 of t, S2 of t, S3 of t, S4 of t are given here. We have to find the number of basis functions is required to represent the given force signal. And the second one is find the orthonormal basis functions, that is phi1 of t, phi2 of t, phi3 of t and phi4 of t. Here we have four signals S1 of t, S2 of t, S3 of t, S4 of t, so that m is equals to 4. Therefore, n should be less than or equal to m. Therefore, we can consider n is equals to 4 and m is equals to 4. In the step 1, we have to find basis function phi1 of t for the signal S1 of t. To find phi1 of t, the formula is S1 of t divided by square root of E1. We have to find E1 and the formula is integral of 0 to t S1 square of t into dt is equals to integral of the limit is 0 to t by 3. S1 square of t is 1 square into dt is equals to, we will get t after integration and the limits are 0 to t by 3. We will get t by 3 after applying the limits, we will get t by 3 minus 0 and the E1 is t by 3 joules. E1 is energy. Now we have to find phi1 of t, so that S1 of t divided by square root of t by 3. Here E1 is t by 3. Therefore, S1 of t into square root of 3 by t. Here reciprocal. Then S1 of t is 1. Then phi1 of t is square root of 3 by t. Here we have constructed the graph. Then phi1 of t is equals to square root of 3 by t to the limits 0 less than or equal to t less than or equal to t by 3. 0 otherwise. Now step 2, g1 of t is equals to s1 of t minus summation of j is equals to 1 to I is equals to 1 s1j phi j of t. g2 of t is equals to s2 of t minus j is equals to 1 summation of 2j phi j of t. g2 of t is equals to s2 of t minus s21 phi phi1 of t. We know that here we have to find s21 is equals to integral of 0 to t s2 of t into phi1 of t dt. Here limits varies from 0 to 2t by 3. Integral of 0 to 2t by 3 s2 of t here is 1 into phi1 of t, we got square root of 3 by t into dt. After integration, we will get t to the limit 0 to 2t by 3. Finally, we will get, after simplification, s21 is equals to 2 into square root of t by 3. Now, we have to find g2 of t is equals to s2 of t minus 2 into square root of t by 3 into phi1 of t. We have to plot the graph of g2 of t. We got 1 to 2t by t, then 1 to t by 3 and 1 to t by 3 to 2t by 3. Here we have plotted the graphs of g2 of 3. Then we have to find phi 2 of t. Phi 2 of t is equals to g2 of t divided by square root of e2. Eg2 of t is equals to integral of 0 to t g2 square of t into dt. Integration of t, here the limits varies from t by 3 to 2t by 3. 1 square into dt. After integration, t to the limits t by 3 to 2t by 3. Here, after simplification, we will get 2t by 3 minus t by 3, and energy 2 we get t by 3 joules. Now, phi 2 of t is equals to g2 of t divided by square root of t by 3 is equals to g2 of t square root of 3 divided by t. After simplification, we get 1. Here we plot the graphs here, and E phi 2 of t is equals to integral of t by 3 to 2t by 3 phi 2 square of t into dt. Integral of t by 3 to 2t by 3 square root of 3 by t whole square dt. After simplification, we get E phi 2 of t is equals to 1. When it is equals to 1, it is called as orthonormal. Now we have to find the no overlap between phi 1 of t and phi 2 of t. We already found out phi 1 of t and phi 2 of t. Now we have to find step 3. G1 of t is equals to S1 of t minus summation of j is equals to 1 to I minus 1. J Sij phi j of t. Si of t will become S3 of t minus summation of j is equals to 1 to 2 S3I phi j of t. S3 of t minus S31 phi 1 of t plus S32 phi 2 of t. G3 of t is equals to S3 of t minus S31 phi 1 of t minus S32 phi 2 of t. We have to find S31 integration of 0 to t S3 of t into phi 1 of t into dt. We are substituting S3 of t as 0. Integral of 0 to t 0 into dt is equals to 0. Now S31 is equals to 0. We have plotted the graphs here. We have to find S32 integral of 0 to t S3 of t into phi 2 of t dt. We have plotted the graphs here, and S32 we will get square root of 3 by 2, and the limits varies from t by 3 less than or equal to t less than or equal to 2t by 3. S32 is equals to integral of t by 3 to 2t by 3 in square root of 3 by 2 into dt is equals to square root of 3 by t into t of the limits varies from 2t by 3 to 2t by 3. Then after simplification, we get S32 is equals to square root of t by 3. Now G3 of t is equals to S3 of t minus S3 phi 1 of t minus S32 phi 2 of t. After simplification, we will get G3 of t is equals to S3 of t minus square root of t by 3 into phi 2 of t. We have plotted the graphs for above simplification, and now we have to find Eg3 of t is equals to integral of 2t by 3 to t g3t into dt. Integration of t by 3 2t by 3 1 into dt is equals to 2t by 3 minus t by 3 is equals to t by 3 joules. Now we have to find phi 3 of t. Phi 3 of t is equals to g3 of t divided by square root of eg3 of t. G3 of t divided by square root of t by 3, we will get phi 3 of t is equals to square root of 3 by t g3 of t. And the plot for the above simplification is here. Then for no overlapping, we have plotted the three graphs below. Step 4. Gi of t is equals to Si of t minus summation of j is equals to 1 to I is equals to 1 Sij phi j of t. Here I is equals to 4 because we have considered 4 signals. G4 of t is equals to S4 of t minus summation of j is equals to 1 to 3 S4j phi j of t. S4 of t minus S4 1 5 1 of t plus S4 2 5 2 of t plus S4 3 5 3 of t. Therefore, G4 of t is equals to S4 of t minus S4 1 5 1 of t minus S4 2 5 2 of t minus S4 3 5 2 of t. For S4 1, we have integration of 0 to t S4 of t into 5 1 of t dt. And the plots for the above simplification is given below. Now S4 1 is equals to integration of 0 to t S4 of t into 5 1 of t dt. Integration of 0 to t by 3 square root of 3 by t into dt is equals to square root of t 3 by t into t of limits varies from 0 to t by 3. And the after simplification we will get S4 1 is equals to square root of t by 3. For S4 2 we have integration of 0 to t S4 of t 5 2 of t into dt. And the plots for above simplification is given below. We have S4 2 integration of, as I said above, the formula for this is integration of 0 to t S4 of t into 5 2 of t dt. Limits varies from integration of 0 to integration of t by 3 to 2t by 3 square root of t by 3 into dt. We have square root of t by 3 by t into t. Integration varies from t by 3 to 2t by 3. Now we will get S42 is equals to square root of t by 3 after simplification. For S43 we have integration of 0 to t for S4t 53 of t dt, and the plots for the above simplification is given below. For finding S43 we have integration of 0 to t S4 of t into 53 of t dt, integration of 2t by 3 to t square root of 3 by t into dt. After simplification, we will get S4 of 3 is equals to square root of t by 3. Now, G3 of t is equals to S4 of t minus S4 1 5 1 of t, S4 2 into 5 2 of t, S4 minus S4 3 into 5 3 of t. The plots for S4 of t, for the G3 of t, the plots here are given below. G3 of t becomes 0. Therefore, G4 of t becomes 0. Phi 4 of t also becomes 0. Thank you for watching my video. For more informative videos, please like, comment and subscribe my channel.